Hello. Uh, so this will be in this week. We're gonna start, not start. We have actually started this module already. So the name of the module is three-phase transformer. So this will be the last lecture. This is module number 3, three-phase transformer. So we have done delta delta and Y connection last week. So this time we are gonna do delta Y delta connection. So if I click on the lecture material, you'll see experiment number 10. So these are the connection. We've already covered the basics of it. So Y or del del. So now we are gonna do a combination of it. So this is del connection, as you've already know. This is Y connection. So in case of a del connection, the phase voltage and a line-to-line voltages are same, but in case of Y connection, they're different. So if it is 93 kilovolts, then the line-to-line voltage will be 161 kilovolts. But in the case of del, the current is different. So the line currents are larger than phase currents. So it's when it comes from, say for example, phase A, it will be split into two sections here. So, but in case of Y connections, so the line current and phase currents are same. So we are going to, I'll show you the video in a couple of minutes, but this is the circuit diagram. So initially we're going to do this one, which is we'll supply the power from this side and we'll supply to the Y connected primary side of three-phase transformer. And this, since Y has neutral, so this will be connected to the neutral of the power supply. The secondary is this one, and the load is also secondary, sorry, del connected. So, yeah, and there is no connection. Literally, there is no connection between the primary and secondary. So there is no connection, even if it is Y connected, the secondary side, there won't be any connection from this neutral to the other neutrals. So there will be, so this is one of the best trade-offs of having a transformer. In some of the applications, transformers are used for galvanic isolation. So that is also, this is very important. So then after doing this, we're gonna perform this one and we'll see how the measurements are done and everything. So let's talk about a few more things. Why we need these sorts of combinations. So if we look at this figure, so this is a power system has 4 different parts. One is generation, then transmission, distribution, and consumption. So from the left hand side, if we start, this is the generation part. So normally the voltage range, let me just, so for generation purpose, normally the voltage range from the generator is 11 kilovolts, 15.5 kilovolts. Then transmission line, if we use this amount of voltage, then the I square R losses will be huge. So in order to actually reduce the amount of current, we step up the voltage to, in some cases, 1000 kilovolts. In some countries like China, intercontinental connection, they use 1000 kilovolts range. So let's focus in the middle. So 500 kilovolts is the transmission line's voltage level. So we use a transformer. This transformer is called power transformer. So on the primary side of this transformer, transformer is connected to the generation side or power plant. So on that side, the connection is normally Y connected. On the other hand, the secondary side, which is connected to the transmission line, is normally connected in Dell fashion, Dell manner, Dell configuration, whatever. So why is that? Because if we use Y connected transmission line, then there there should be uh, there should be four cables. But if we use Dell connection, in that case, the power lines are only 4 wire. Sorry, 3 wire. So that's one of the reasons. In some cases, I have seen transmission lines use another cable, which is for protection. But mostly they use, in general case, they use Dell connection. Then if the voltage level is going below 100 kilovolts, then we call it distribution. The distribution sections may be in several steps. It might be 100. If it is 120 kilovolts, so transmission lines can be divided into subcategories, but I'm not going to go into the details of that. But if it is below 100 kilovolts, then we're going to name it distribution. So distributions also has similar categories like transmission. If it is for the distribution, power distribution is for industrial load. In that case, the voltage level will be higher, the transformers rating will be higher, and the connection of the primary and secondary might be different. So industrial load might be they're taking 33 kilovolts, in some cases 11 kilovolts, in some cases 15 kilovolts. So normally in distribution section, the distribution line normally in China or in English, like European countries, they use 11 kilovolts on the distribution line. After the transformer, the voltage is stepped down to 400 volts, so that in residential loads they can get 220 volts. But in the US, it is the residential loads normally take 110 volts. So that is the reason, like, why I'm actually talking about this, because we're studying the different combinations of transformers connection, three-phase transformer connection. So here we can see on the power generation side, Y Dell. In transmission side, it might be Dell. In distribution, Dell or Dell Y. So we need to actually know about these sorts of arrangements and combinations. So, the combinations of these three-phase connections, if we consider load also, that case, it might be load, it might be generation. So the combinations are like this. So primary side may be Dell, secondary side may be Y, and this may be Dell Y, Dell, and load side maybe Y, Dell, Y. So this is the connection. So normally we'll see in power system these top two, like these two. So that's why in today's experiment we'll see that I'm gonna conduct these two, and I would like you to actually take reading of each case. So in this table I have shown like 20 supply voltages, 20, 25, 30, 35, 40, 45, 50. But in while I was doing the experiment, I used some other values, so you're going to use that one. So our target is to measure supply phase voltage, then load side's phase voltage and other values. Then we are going to calculate line to line voltage, line to line currents for each case. Okay, let me open the video. Okay, so this is the first case where we'll see Y connection, Y del del. That means the primary side is Y, secondary side is del, and the transfer or load is also del. Let's see. Hello. So this is the setup for today's experiment. One of the setups, because we are gonna do two setups. So this is, if I go to experiment number 10, it says delta Y and Y delta connection. So we're gonna test them both. So the first connection is like this, del Y and Y. So it means that we're gonna connect the primary as del, and power supply will be connected from ABC power, ABC lines, and this is the secondary side, so which will be connected in Y arrangement, and the load is also connected in Y arrangement. So we're gonna test this one, and also there is another connection. The initial one or the primary one is connected in Y connection, and secondary one is del, and the load is also del. So we're gonna test this first because I have already connected this one. So we need to actually focus on this matter is on the primary side, which is Y connected, there is a neutral. So that's the neutral connection, so it will be connected to the power supply. And on the delta section there is no neutral, so delta I mean the secondary section, so there is no neutral because this is del connected in del manner, and the load is also connected in del manner, so there is no neutral. So we will connect it like this. So let me show you the circuit. So this is the 3 power supply from phase A. This is phase B, and this is line A, B and C, and this is neutral. We all know this, so we are gonna connect this power supply to the primary side, which is the top one here, and the bottom one will be connected to this load. So we need to measure. I told you, I showed you a table. We need to actually measure some values. So on the primary side, which is the Y connected transformer, excuse me, so we need to measure phase voltage. So we are going to measure this amount of voltage. So we are going to measure phase A's voltage, and on the secondary we are going to also measure phase A's voltage. Then we will calculate for primary side, we'll calculate the line to line voltage. On also secondary side, we're going to calculate the line to line voltage. So for that, this A should be connected to this power analyzer. So this is A, and this is the neutral coming from the power supply, and this A is going to one of the windings, which is phase A's winding, this one H1, and this neutral is also going to here at A phase. So as I told you that initially that the primary is connected in Y manner. So let me explain the circuit. So if this is phase A, this is A, and this point is A bar. Let me actually place the circuit, like cables are actually disturbing me. Okay, so this is A, and this is A prime, and this is B prime. This one is C, this one is C prime. So in Y connection, if I look at the figure once again, so Y connection, all the primes are connected in one junction and it is connected to the neutral. So since this is the neutral, so this should be the A phases H5 should be connected to, with this banana cable is connected to H5, and here this is connected to H5 as well, so for the C phase. So the Y's are done, that means this is done. Now phase A, so this is already connected, I told you, via this power analyzer. But what about B? This is the blue cable, so this is connected to B terminal, and this black one, which is C, is connected to H1 terminal, which is C terminal. So that's all for the, what is it called, primary side. Now we are going to talk about secondary side. So secondary side, if I look at the circuit again, so this is del connection. So if this is X, and this will be X prime. So, and this, if this is Y, then this Y should be here and Y prime should be here. So all primes are connected to all actual terminal. So if this is A, this is A prime, this should be B, and this should be B prime, and this should be C, and that one final one should be C prime. So let's look at the transformer 1. So this is the secondary side, that means this is X and this is X prime. So if you look closely, this X prime is connected to the next terminal, which is B, and same not B, sorry, Y, and Y prime is connected to Z, and this Z is open, so I need to connect this to this X prime. So I will need another cable. Let me bring, so I have to connect this Z prime to here A. So now the circuit is done, del connection is done. Now let's look at the load. Let me open this connection so that I'll be able to, it'll be easier for me to actually explain. So this is A, this is A prime, B, B prime, and C, C prime. So A prime should be connected to C, and this A is connected to B prime, B is connected to C prime. So this is the way I have done it. So now the secondary power supply, how we are going to supply the power. If I look at the circuit again, so see, this is going to one of the terminals, this is going to another terminal. So there are 3 terminals, so A should go to A, B should go to B, and C should go to C. So this is A, I'm taking A and I'm actually feeding it to the power analyzer. So this is A, and this green one is this one, so this is B. So I can connect it either way, like this point or this point, they're connected, so that doesn't really matter. And one thing is, although I have started when I started talking about this, I have mentioned that we're gonna measure the phase voltage of the primary side and the phase voltage of the secondary side. So since this is connected in del fashion, so the phase voltage and line voltage, they're same. So even if I'm saying that I'm measuring phase voltage, I'm also measuring line voltage. So that's all. So I am taking these 2 inputs and feeding it to the power analyzer, and then this is going to, the red one should go to A, and the green one will go to B. So that's about it. So we're gonna measure some values here. We're gonna change some voltage, supply voltage. So this is also on. So we're going to increase the voltage here. So I want you to measure every point here, like the watt, power factor, voltage and current. So initially we'll start with 20 volts. So these are the values. I'm not gonna spell out everything, so please take a measurement, take a note. And on the secondary side, for 20 volts, I'm getting these values. Okay, now I will change the voltage to 30 volts. So that's 30 volts, approximately 30 volts. So these are the values of the primary side, and on the secondary side, these are the values. I will change again the voltage. This time I'm going to take 50 volts. So that's 50 volts. Okay, that's 50 volts. So this, you can see this is negative 0.1. Actually this is not accurate. This should be somewhere 2 watts, 2.9 or 3 watts. We'll see. So these are the 4 different values. Please consider this as a wrong one, and like it should be 2.9. and here's the secondary voltage and other values. Let me increase the voltage even further. Let's go to 70 volts. Again, I don't know why this is not showing exact value, so it should be around 5.5 or 5.4. So these are the other values. So remember, this is wrong, and the secondary voltage and other values are like this. Okay, now I'm gonna change the voltage even further. Like I'll go for 100 volts this time. Okay, that's about it. So again the power is not showing accurately. It should be 11 or 10.9. so yeah, on the secondary we have these values. So that's all for for this arrangement. I'm gonna pause the video and I will connect this circuit. So it will be primary side will be del, and this will be the secondary will be Y, and this will also be Y. Okay, let me open the second one. So now that I've connected everything according to this file, which is del YY, so the primary is connected to the power supply, and the primary's connection is del, and the secondary is Y, and the load is also Y. So in both cases we're going to measure the phase voltages. So yeah, let me show you the connection first. So these are the three phase connection, A, B and C. Since in del connection there is no neutral, so we are not going to use neutral here. So these A and B are coming to the power analyzer here, and this A and B is the output of this power analyzer, which is going to the primary of this this three-phase transformer. So this is A and this is B, and this C is coming from directly from the power supply. So we are measuring, since it is a del connection, that means the phase voltage and line voltage or line voltages are same. So we are going to measure that. And on the secondary, which is Y connection, so this is A, this is B, and this is C, and these are this and that one is the neutral. So from here, which is the secondary, we are going to power these three phase loads. So these A, since we want to measure A phase voltage here, so we are going to take one of the connections from here and supply it to this power analyzer. Then we'll take one of the nodes from the, what is it called, neutral, and connect. So this is A and this is neutral. So, and from here, this A is going to directly to the A phase of the load, and the B phase is coming from directly from the transformer, not from the power analyzer. Anyway, so and same goes for C. So this is C and this is coming from here. And so let's start the circuit. So we're gonna supply 20 volts first. Oh, I haven't actually turned this on. Okay, so that's 20. Okay, that's 20 volts. So I'd like you to actually take a reading of these four elements. So I have changed the power analyzer here, so that's why you're getting some sort of like corrected value. So please note them. So for this arrangement, this will be the secondary. Okay, so that's 10 volt. So now let's go for 50 volts. Okay, for 50 volt, I'm getting these four elements: watt, power factor, voltage, and current. I'm getting these four measurements from the secondary side. So I'm going to increase the voltage to 75, let's say. So okay, so for 75 volts, these are the input or supply side or primary side values, and on the secondary side you can see the values are like this. You will notice that the output power here is 2.3, whereas in the input side it is 7.5. It is because we are only measuring the phase elements here, so that's why the power of the output is so low. Anyway, let's bring the voltage to 100. So this is for 101.1. so the input power is 13 watt. On the other side, the output power is 4, power factor is 0.539, and voltage is 49, and the current is 0.149. So I'd like to take those readings for this circuit and do all the required calculations. Thank you. So yeah, let me go back to the canvas. Yes, so I have actually given you everything, so I want you to actually fill up the table for each case and calculate the line to line voltage, line to line current, phase voltage, phase current for the primary side and the secondary side. So that's all for today. And one more thing. So I have noticed that my space for files, like in the canvas, is filled. So I'll have to actually delete some of the videos, older videos. So if you haven't actually downloaded any of the materials yet, if you if you think that you need those videos, so you can download them, uh, because I'm gonna delete them anyways. So that's a heads up. And in next class, we are going to actually experiment. Uh, we are not going to experiment anything like that. We are going to use Simulink for experimentation. So that's a heads up for next week's class. I hope you'll have a wonderful weekend. Thank you so much.